3, 2, 1. Hello, everyone. Good afternoon. Thank you very much for joining I think it's the 6th or 7th already, Epic online technology meeting. And we are extremely happy with the way that we managed to bring the Epic world to the online world. For those who don't know me, my name is Jose. I am the CTO of Epic, the geek of Epic, the guy who loves photonics and the guy who loves his job, I think almost as much as each one of you. So for those of you for whom is the first ever Epic meeting, I would like to tell you the first rule of Epic events. Do not be shy. Epic events are a reason for us to find ways of working together, and that's what we want to do in the coming minutes. So let me first of all show you a couple of things that I want to share with you. The first one is
what to do with the concerns on the
I think I'm getting some return from some of you. So let me kindly ask you to mute. So basically this is, let me check, it's the 5th ever Epic Online Technology meeting. Today we focus on LIDAR for automotive. Epic is a platform, a technology platform of 550 now members. We have now also 6 people with a PhD whose job is to understand the technology of these 500 members and to make sure we find the connections, the links between your potential partners, suppliers, and customers by giving you market reports and also by organizing great meetings. We used to organize great meetings at company locations. Now we organize great meetings in Zoom and in YouTube, and we organize meetings in which you don't have to move from the comfort of your own desktop. We cover every single technology and application from LEDs, biophotonics, optical fiber, photonic integrated circuits, and we try to approach different market segments from automotive to industrial manufacturing, of course, data and telecom, and we try to always bring the key companies of a particular sector, technology and market, to a particular location. This is the calendar of events when the situation normalizes. I think in almost every location, the curve is now flattening. We are getting to the peak soon. Hopefully soon, the situation will normalize and we'll see each other again in one of our upcoming meetings. This is the calendar, and you can see, for example, on the 29th and 30th of October, we had the Epic meeting on automation for manufacturing, in which the companies that are looking to develop a new optical instruments, they can come and they can find the whole supply chain and understand how they can work together. So today, LIDAR. It's not the first meeting that we organized in LIDAR. Actually, it was the last October we organized a meeting in Eindhoven on Epic, on LIDAR technologies fully focused on automotive. And there we had the companies, one of our speakers from LeddarTech, where LeddarTech was also represented in the previous meeting that we had on LIDAR. And what I would like to tell you is that we organize the meetings for you to keep that knowledge. So please remember that every meeting in the last year was recorded, was filmed, and all the content that was collected from all these meetings can be found in the website www.epic-events.eu. So please make sure that you visit it, you check the different meetings that we organized. The one on LIDAR was Epic, and please make sure that you also have a look at the presentations, both in video and PDF, and most important, if you want to interact with any of the speakers, you contact us and we'll make sure that we find the proper introduction. And also for those of you who are looking for talent, who have job openings, we are creating the biggest website for jobs in photonics. So all our members have been scouted. We look at the technology that they are doing. We look at the website with the open vacancies. We are posting it there. We are actually scouting talent worldwide. So this will be the biggest thing we're going to do next year. We started already. It's great. We are really collecting so many job openings, and we really want to help the industry focus. But today's LIDAR, and this is the menu that we have for today. I am so happy that we have companies like Ibeo, like LeddarTech, like JENOPTIK, Smart Photonics, Hamamatsu. When marketing gives me the calendar like this, I look at it and I get excited, but then I shift it a little bit, I look at the participant list, and I make something like this. These are the companies who, in the last 2 weeks, have given us input and have registered to attend today. Our idea is to make sure that the end users, companies like NVDA, like the European Space Agency, already told us the challenges that they have in terms of field of view, in terms of wavelength, in terms of eye safety, in terms of power, and in terms of the kind of quality they need for the optics, the kind of coatings that they need, the kind of packaging process, the kind of validation process, the kind of price. We have this information. We need to match it with what each one of you can provide. So we have companies who are making light sources, companies like Modulite, like Monochrome, and Lumivert, companies who are making the different integrated photonics for the next stage into miniaturization. So companies like LeddarTech, Smart Photonics, imec. The idea is to really make sure that we find the link for those of you, for all of you, to find reasons of working together. And with this, I would like to give the floor to the first speaker today. It was great to have a company like Ibeo. Ibeo is the kind of company that covers the value chain from buying already components, even big sets, and integrating them and offering this already to automotive companies. So it is a tier 1 supplier, but actually connects the photonics value chain directly in the automotive market. So it's one of those companies that at Epic we consider key, we consider node, and we are very happy to have Ünsal Kabuk, the head of research and advanced development at Ibeo Automotive, to be our opening speaker today. Thank you very much for being with us this afternoon. Thank you for kicking this fantastic event today. I hope the attention of everyone and of course the potential business opportunities are here for you.
Yes, hello. Thank you, Jose, for the very nice introduction. Was perfect. My name is, first, hello to everyone here in the channel, and hello everyone outside on the YouTube channel also. So my name is Ünsal Kabuk, and I would like to talk a little bit about our technology. And first I have to switch on the slides, of course. So now you should able to see the slides. Yeah, perfect. Okay, so so let's dive in to my talk. Yeah, okay. So first of all, I would like to cite Mr. Murakami with a very special sentence for me. It always inspires me to think a little bit out of our boxes, and this is why I like meetings like EPIC. And so bringing so many peoples together from cross industries, and so we can have this occasion to speak to each other. So thank you very much to EPIC also for this EP series of talks. Today we have a very short agenda, so I would like to tell a little bit about Ibeo and our technology and what we offer, and to come together with all of you. Some key facts about Ibeo. Our headquarters are in Hamburg. We are around 400 employees around worldwide. And what you may know is that we are a high-tech company in the field of LIDAR sensors. Sometimes it is not very well known that we also have all associated products with it. So we have a software development in place for sensor fusion and perception software. And also we have a big group developing autonomous driving functions. They have very nice projects with shuttle suppliers, for instance. One thing I would like also to emphasize is that we have a subsidiary in Eindhoven, so where the last EPIC meeting was, and they are the competence center of our simulation. So environmental simulations with different sensor modalities, LIDAR, radar, and camera. They have it in place, and they are developing very nice software suites for this. So whenever you have the chance to go there to visit them, please do. They're doing a really great job there. Yeah, okay, so some of you may know that we are developing our new cutting edge technology, and I would like to introduce a little bit about our new technology. So we have a brand new logo and the brand developed for it. We call it Ibeo Next. And what you see here is something fully true solid state, so absolute no moving parts. On the right, you see one of our unique selling points. So we are smaller than a credit card, And that's everything what you need to produce a 3D point cloud on the right. So, and this is possible through, let's say, highly integrated semiconductor chip development on the transmitter and the receiver side. You see that we have the signal processing unit embedded in our receiver part. So we have ability to have a high-speed signal processing of the data for this long range and high density data we can get. And on the left, we have the transmitter array, which is a VCSEL. So we have an adjustable VCSEL array there. To my knowledge, it's very unique. So it's ability to have a high power output and with the highest efficiency in the market. So this allows us really to have a long range and long high performance sensor. Another thing what we would like to emphasize is that would like to emphasize is that we have a 3D point cloud and an intensity image. And what this means, I would like to show on the next slide. So I brought a small video. Let's try if it is running. So this is, by the way, one video from our customer with a dual head integration. It's looking forward, and it's on a highway. So the car, the ego vehicle, is driving in ACC mode on a highway. And the blue boxes, what you see here, are tracked objects, dynamic objects here in this case. And in the middle, you see the 3D point cloud. As a reference, we have a standard video camera. And on the right there, you see the individual intensity images, what I meant. So you can imagine that we have intrinsically built-in camera, what is fused with our LiDAR data. So we can have a lot of processing options in 3D and also in 2D. And it is much better, the amount of details what we see on the roads is much better seen on the right side and the intensity images. And we see the line markings, we see the truck, we see the individual cars we have here, and even we see the opposite side of the traffic coming here. So we have a wide field of view, and it was a high resolution achieved with our systems. This, what we believe is is an enabler and a door opener for ADAS up to level 5 of applications. And yeah, so it gives us a much more robust data here. Okay. It's always in a loop, so okay. So what we offer, yeah, okay, we offer definitely a high performance sensor. By the way, it is you can order it by now. So this is something what we developed so far, and you see that our start of production is very soon for automotive mass market. It's 22, and we are targeting this as to be the first in the market for true solid state system. And yeah, so if you have projects and applications out there to where you need a LiDAR, we have teams in hard and software integration support. So we can provide all these actions to match your applications. Another thing I would like to emphasize and show, maybe it's a little bit early, but please book it on your calendars. It's the ITS World Congress in Hamburg. So since it's our headquarters, it's like playing in our home city. So we have a very good occasion to show very nice demos. So we are planning very ambitious demos there. So please come and connect to us to see what we have for plans. Additionally, we always look for let's say technology development to develop our technology further, and we are doing European funded projects, so we are open for very nice proposals to discuss and collaborate with all you guys out there. Yeah, okay, thank you for your attention. This was my end of my talk.
Thank you very much for the great presentation. We had a constant white noise, but the message had enough SNR for us to collect the whole information. So I have a lot of questions, but the most important is this is an epic meeting. It's not a conference, an epic meeting. We're here to find collaborators. So
Yes.
could you summarize the answer to the key epic question? What can you do for them, for the rest? What can they do for you?
Yeah, okay. So since, like I said, we have LiDAR sensors, we have teams with softwares. So everyone who needs a sensor in his application, we can give support to integrate them into their application with software and hardware. Another thing, what we look for is to have, let's say, a deeper dive into several other industrial branches. So like real industry or drones. So we're looking for very good partners on that point and to collaborate with them in their technologies and to support them with our competence.
Fantastic. Are there any questions for Ibeo? Not every day we get the chance to ask questions to the head of page for R&D at Ibeo. One of the questions actually coming from the YouTube channel. Hello, YouTubers everywhere. The YouTube channel is Olivier from Lumibert. Hello, Olivier. He's asking, how can you achieve 300-meter range with a class 1 diode laser?
Yeah, okay. This 300-meter range is the total range we can provide on certain objects. So this must not be the object with the smallest reflectivity. So it could be a car or a truck or a big sign or a bridge, what we can see. So there are enough points onto these targets to have a higher probability to detect them even in a longer range. So this is not the same story if you have a small obstacle where you need to have only 1 or 2 points on it. And per pixel, you have to have a lot of SNR to detect them. So these are two different numbers and to relate to each other.
Mm-hmm. Okay. So in previous meetings, we discussed a lot about the needs for pixels at Ibeo. First, could you specify for us the Santa Claus Christmas list for the ideal pixel you would like to have in your inbox?
Yeah, okay. So the ideal pixel is something which has a lot of addressable pixels. The best thing is if they are individually addressable, so not in lines or in rows or columns. So individual pixel addressing, and one individual pixel has a lot of emission power. And yeah, so these are two things. At the end, we have to support field of view with high resolution and long range.
I have here with us a good friend of mine, Julian from 26. Hey, Julian, how are you doing?
Good, thanks. Actually, how did you know I wanted to ask a question?
Because I asked about pixels and I was looking at you. You don't know that, but I'm looking at you constantly when I think about pixels. Julian has a question for you, Julian.
Yeah, so you mentioned a few points that you really like for pixels. What about the wavelength? Is there, I think right now you're using 940, but is that the ultimate wavelength or is there a preferred wavelength?
No, currently we are using 885.
Oh, okay.
So this is what we have. But looking on a longer term, we would like to switch to 940.
Okay, so 905 is not of interest to you?
At the moment, not. So we have, let's say, the Scala sensor. This is the formerly sensor we have put in the market, in the automotive market with Valeo. It's running in 905, that's right, which is an edge emitting solution. But for the pixels, we would like to jump from 885 to 940.
Thank you.
Yeah.
Any further questions? If not, I love when Epic members get to know each other. There's a company in Epic, a company in Barcelona. It's called Monochrome. And Monochrome make laser diodes. I would like you to get to know them. We have a representative from Monochrome here. Hello. Thank you very much for joining us this afternoon. I would like to give you a few seconds to explain our friend from Ibeo what Monochrome can do for them.
Okay. So Monochrome is focusing on diode lasers. So edge emitting diode lasers is one of our main competence and expertise. We have, in general, all wavelengths available that are common on the market, as well as now we also have a research project with 2 micron laser bars. We are trying to clamp them because I mean, one of the main difference between us and other of our other competitors is that we do not solder our laser bars, so we make a sandwich and clamp them, easily spoken. So yes, and this has some advantages in terms of reduced smile and better cooling performance.
Igor, monochrome has made a big impact in EPIC in the last 2 years in markets like material processing, in the dermatology. I want to say also in the defense. How do you approach the LIDAR market for monochrome? What is the positioning that you want to take in this sector?
So LIDAR market is quite new for us. So it would be nice if we can step into that. I mean, we can develop superb solutions with solid state lasers, with semiconductor lasers. So we are always open and willing for collaboration. All
right, one more question for Ibeo. Detectors. We have many companies in EPIC who have developed different kind of detectors. I would like to see what is your view for SPADs. What kind of ideal SPADs would you be looking at after this meeting?
Yeah, so okay, this is something what we are looking for to develop in our research activities, definitely. So it's an ideal SPAD detector array should be something what would have a lot of channels, so at least VGA resolution or more. So up to now, I didn't see any paper for SPAD detector having this kind of resolution for a long range LIDAR application, and especially should have a high PDP with 10 to 20% at 940. This would be very nice, of course, and definitely having smart possibilities of selecting and addressing individual areas within the chip. So this is something we are definitely looking for.
Let me introduce another friend of mine from a company called Fast3 3D, our friend Claude Florent. Claude, how are you doing today? Claude is the founder of one of these promising startups in this ecosystem. Claude, you have been using SPADs from the very beginning. It was an icon part of the LiDAR camera you want to develop. How do you foresee the development of SPADs, and do you have the whole supply chain ready for this?
Well, we are a small startup, and actually Ibeo and other people know a little bit our situation, but I could say first put the claims as our co-founder just published a 1 megapixel SPAD array. So in a sense, we are shooting for quarter QVGA system on chip. So we believe that the scalability is possible. The challenges are multiple, but I would say the first one is the compute powers. You need to move to technology where the readout, the histogramming is quite powerful. That's what we're doing. But typically, that's one area. We also, one of the companies that produce 3D stacked chip to put the computing, histogramming of SPAD for Ibeo understands that fairly well. Below on the layer under the photo detector. That's one of the comments I would make. So the scalability of large array SPADs follows what the scalability that happens in digital imaging. The other part that you discussed was the PDP. That requires more, and I'm sure you guys know very well the answer as well. That requires a more subtle answer, because if you increase the PDP too much, and again, it's been shown that you can reach 20%, yes, in silicon, but then you're going to be overwhelmed by the background illumination. And as you also, certainly for Ibeo, I know, but for other players, you need to work around these background noise illumination with various tricks. One on which we work a lot is coincidence management, as using multi-pixels to make sure that you can make a difference between the sun and your laser. But for all these reasons, you don't really want to increase PDP so much. Okay, that's a general comment.
Thank you very much, Claude. And a small start that you're creating so much noise, and everybody knows so well fast 3D, you are doing the right things. We have a final question for Ibeo from Emeka Consulting. She's specializing in consulting of photonics and quantum technologies, very engaged with EPIC. She's wondering, does Ibeo work on lighting and LIDAR integration?
Can you please say
Is
the
there
question again?
any R&D line or any line of work for Ibeo trying to integrate modules for both lighting and LIDAR together?
Yes, we have. So we have some projects together with one major German company for lighting. So it's Hella, and we also have separate projects with other OEMs. So integrating the headlamp, lighting, and a LiDAR is always something which is asked for, and it's not easy because the curvature of the front glass is so arbitrary, and it's something you don't control so much, and the optics is very challenging to integrate it there. So, but we have R&D actions definitely there.
We're also working with Hella in one project in which we are bringing micro optics for the automotive sector, and we are developing a special free-form micro optic to actually integrate these two. But as you said, it's a huge, huge challenge. Any final question before we move on to the next speaker? All right, thank you very much. Now you all know how this works. The idea is first not to be shy. If there are no questions, I ask the questions.
I do have one question for Ibeo as well.
Yes, please, go ahead.
How will you deal with multiple LiDAR sensors facing each other on the road, for example? Do you have solutions for that already?
Yeah, okay. So this is a very good question, and this is something what we have in our let's say in the product development chain. So we are looking for solutions and mitigations if let's say all of the cars in the world have a LiDAR. So then you have to have a solution in place. One definite solution is the scanning action. So we are not flashing the scene, we are scanning. So you have space and time slots to hit in the same manner like you emit. So this gives you a certain immunity to reject these kind of disturbances and interferences. And definitely we have things on the algorithm side also for the signal generation and reception for having higher interference reduction probabilities.
Thank you very much, Ünsal, for a great presentation. We move ahead with the program, and today we have the honor of having here the CTO of one of the iconic worldwide companies in LiDAR, LeddarTech, Pierre Olivier. Thank you very much for being with us this afternoon. The attention of everyone is yours.
Okay, let me just try and pull my presentation. Hold on, I think this is this year.
Fantastic.
Okay, well, so first of all, good day, everyone. It's truly an honor to speak here today, although it's very unusual circumstances. So I'm talking to you today live from my basement in Quebec City. Okay, so first of all, I want to find how I change my slide is going to be the first. Bear with me. Okay.
Only the space bar, that's the job.
Yeah, I found that. Thanks. So, okay, so first of all, I want to take a few minutes to reflect on where we stand today on the road to autonomous driving. So really, if you go back a couple of years ago, there's been some pretty bold predictions as to how quickly automated driving level 4, even level 4 and level 5 would be achievable. So if you believe the hype, we'd all actually be riding into automated vehicles today. But unfortunately, the reality caught up to the industry, and some of most players have had to backpedal a bit on some of these commitments, to the point where today you have people that think that it's going to be decades before we have fully automated, like level 4, level 5 vehicles on the road, or there's even some people that argue that it will never happen. So, which, well, never is a very long time, but certainly there's been a shift in the claims and in the hype around the industry, which really, as vendors, we're all suffering from to a degree. So we're all suffering from this sort of lack of delivery or lack of credibility that the industry has built. Really, well, what has happened is really it is difficult, and it is a very challenging problem, and certainly as more deployments happen, there's also more, unfortunately, accidents that happen, and really the public in general gets more and more aware of the challenges, of the risks, and of the difficulty that's attached to the lack of maturity of this technology. And what's even more surprising and even shocking, I would say, is that even some functions that are really deployed in volume today, such as, like, for example, the automatic emergency braking. Well, these solutions, they're providing only marginal performance under real life conditions. So really, there's a lot of work that needs to be done before we achieve consistent performance, and we achieve something that can be let loose on the road. Okay, so who LeddarTech is and what we're doing to try and help to achieve that. Well, first of all, we're one of the oldest companies in the LIDAR market or for autonomous vehicles. A company, we've been in business since 2007. We've been delivering LIDAR for a large number of applications for over a decade. So we have a lot of experience in the field. Of course, we view automated driving. It's a very promising opportunity. It's massive numbers, but we also think it's such a large opportunity that it cannot be winner take all. Certainly not for the short term. There's way too much work to be done. So what do we do there? Well, ourselves, we view ourselves as we're a technology provider. We're supplying key signal acquisition, signal processing components and software. And really, we truly believe that it's a collaborative approach between the different players that will be required to ensure the successful deployment of automated driving. Because the problem has a large number of dimensions. It ranges from, like, optics, photonics, to artificial intelligence, and really there's no vendor that can be the best in the world at all these disciplines. So it truly means that people need to work together. So what we deliver more specifically, we deliver what we call the LiDAR engine system on chip, which is really the first ASSP, the first chip that's been developed to be widely available for all LiDAR manufacturers, and that has been specifically designed for automotive applications. There's a number of players that design their own solutions, that design ASICs for their own products. We chose to develop a component that would be available on the shelf for people to develop their own solutions. So really, what it integrates the full front end for a full waveform conversion LiDAR. It embeds really our patented signal acquisition algorithms, a large number of parallel acquisition channels. It supports multiple parallel SoCs for high channel counts. It is designed to be ISO 26262 ASIL-B compliant, AEC-Q100 obviously for automotive applications, and also it comes with a complete and a comprehensive signal processing library that embeds really all the measurement functions and also all the other functions that you need to build a time of flight LiDAR. So really this includes and integrates interference rejection, crosstalk mitigation, programmable source control, and so on. So really everything you need to build a module or a LiDAR sensor around. So obviously we include or have eval boards available, development tools, and also we have a partner program that we call the LiDAR ecosystem, where we brought together best-in-class technology providers for components like photodetectors, lasers, optical components. So these can be leveraged to accelerate and to de-risk the sensor development. So we also have complete sensors available. Certainly, for example, there's AV developers that may want to jumpstart their development. They may not necessarily want to develop their own sensor hardware from the ground up. So we have what we call the LiDAR Pixel module. This is one of the modules, our latest that we launched. This is a true solid state sensor. Certainly it covers 180-degree field of view. I say true solid state because certainly there's lots of flexibility in what people call solid state in this industry. There's people, for example, that will claim that MEMS micro mirrors are solid state. Well, this is truly no moving parts, not even micromechanical. So it has very high immunity to shock, to vibration, very high MTBF, and that's especially important for example, some applications like autonomous delivery, for example, where you expect the vehicles to be on the road 24/7. So you need something that's very high MTBF and very high reliability. You don't want the fleet to be down because of a sensor issue. So this is shipping in volume today. So it's we're taking orders. And finally, I want to talk a bit about what we call the LiDAR Sense Perception Development Kit, which was one of our latest and newest initiatives. One of the challenges to AD deployment or development is that you need to build a perception stack for your sensor suite and read to match your operational design domains, your ODDs. For mechanical scanners, there's lots of work that's been done mostly by the academic community today, and that can be leveraged. But for a flash LiDAR, there's very little history on building perception for these types of LiDARs. So certainly that can be an obstacle to adopting the technology, and that's what we wanted to fill the gaps so that the developers would have something to start from, and they would be productive day one. And obviously you saw our approach as far as like the open platform. So we took the same really spirit and the same approach to this initiative. So we were making this an open platform. So people will be able to see and to modify the calibration routines. They're able to see the neural net architectures, they can retrain the networks, they can optimize them and so on, match them to their ODDs. So truly this is meant to be an open perception stack for an open LiDAR platform. So that's really what I wanted to cover for today. So thanks for listening, and certainly open for questions.
Thank you so much, Pierre. We enjoyed hearing about the solid-state 3D flash laser. This is amazing technology. But you know how it goes with epic meetings, right? You tell us what you do, and we also want to know what can the others do for you. What
Absolutely.
are the technologies that you are looking for to complement or improve on your high-tech LiDARs? Well,
certainly always on the lookout for like on the component front. Obviously, as I said, a LiDAR, it's a multidisciplinary thing, and certainly always looking for developments in detector arrays, different emitter configurations. They're like certainly edge emitters, VCSELs. We're I like to say agnostic, but certainly we have an interest in seeing the most choice and the most performance in each of these areas. So certainly we like to talk with component vendors and see what's up and coming.
Does anybody have a question before I continue with my questions? Okay, can you tell me more about the system? Is it possible to have it connected like to the new 5G or Internet of Things?
Yeah, well, certainly. Typically, we don't go as far as what I'd call the driver agent or the upper layer functions of the automated vehicle. But certainly, we are developing even if just to be knowledgeable about what our customers are facing. Certainly we're looking at these things. So obviously there's challenges such as like synchronization and what your round trip times are going to be and so on. There's challenges with the availability of the network, but really there's no concern that these solutions are compatible with either like centralized or distributed processing.
I think Jose has a question.
I have a question with a comment from the YouTube world, Supplier, a company that we are very much engaged with. Andreas, hi Andreas. Andreas, they make vacuum deposition equipment for optical IR filters. And he wonders, does the Pixel 3D Flash Cocoon contain on-chip integrated IR filters?
Well,
filters?
Actually, that's a very good question, and actually, no, the Pixel sensor actually does not need an IR filter. It uses our patented signal acquisition, signal processing, and can get this level of performance with a pin photodetector with no IR filter. So obviously, for longer range applications, we also use APDs that need IR filters. So we're very interested in different like IR filter capabilities, especially the angular response and so on. But this one does not specifically use a filter.
Thank you so much. If there is
I have a question.
Go ahead.
Yeah, this is Vincent. This is, I think you're talking about some of the reliability related issue. Actually, this is where my focus is on. So for the devices, you're talking about MTBF and as well as a long-term reliability on the real application. So how you define that numbers, like any devices, what kind of MTBF you are talking about? And then also, how are you dealing with any like the actual failure in the real field?
Okay, that's a very good question. There's two answers to that. Certainly, this is a new product, so it doesn't have a long-term field history yet. So we tend to use the estimative approaches like the Belcore method, but certainly we have products that use similar architecture, similar construction, where we've been deploying for 10 years and have field measured MTBF, for example, and we have a family of sensors that we use for traffic management, which is a very stable population where we have field measured MTBF that exceeds 500,000 hours.
Okay, good. Okay. Okay, thank you.
I'm very happy you asked the question because you're going to be the next speaker from Facebook, Vincent Zeng. I'm very curious to hear what's your interest in joining EPIC.
Yeah. So the interesting I joined the EPIC is because I'm the end user for photonics, probably not limited to LIDAR, mainly on the optical communication area. Because I'm working for Facebook's data center, so we use a lot of optical networking equipment, and optical transmitter, transceiver is over there. So the problem we're seeing actually is very interesting. So I want to bring to the industry to understand what really we are looking for from the user perspective. So reliability obviously is one of the biggest thing, and then how we control the high quality of the product before leaving the manufacturer going to the end user like Facebook. What is the critical things we're really looking for? So that is, I think I want to share some of our experiences with the industry, and then hopefully for photonics industry will get benefit from that.
Yeah, we're so curious. Please start. You can share your screen now.
Okay.
So on the bottom, you can find the bar where you have the option to share the screen.
Okay. Okay.
Excellent. So now
can you see that? Okay.
Yes, yes.
Okay.
You can go to presentation mode and it will be perfect.
Okay. Presentation mode. Okay. Okay. So thank you very much to having me, and then so be nice to be here. It's an honor to first time to present on the EPIC. I think we have some discussing over several like the OFC, ECOC, many times, and in the peak in the Europe. So I think it's the first time to present here. It's very nice to hear. The topics I'm talking about is I'm in the quality guys. So I'm working for Facebook as a data center for optical qualification and the process control. So my topics today is a practical reliability guidance for the peak manufacturing. So obviously my focus is on how we define the manufacturing process. It's not like in the earlier phases of the product, but in the end of in the mass production of the phases of the product. So the agenda is basically talking about what is the problem we're seeing. And then we're going to briefly mention about Facebook as a data center in scale. And also talking about some of the design for reliability and the robustness. And also try to come with some like quality and reliability consideration in general for optics devices. So the problem statement is that I have been working for Facebook like almost 4 or 5 years, and then have been during this period after we're talking with a different optical manufacturer. So every people is talking about like optical is like in all cases like a small transceiver. If it fail, it's just a fail one devices, but nobody is really imagine that what is one single optical networking, or we call it the port failure, is causing us the problems. So that is why I put in that one statement is optical device failure bring very negative impact to data centers application. We need to spend tons of the money to troubleshooting on each link, as well as the equipment, because of the complexity of the data center. You have a very strong mesh structure. So every single port causing the problem, you need to debug at different location, different site. So that is causing a lot of, bring the problem is like the bigger scale. It's not like owning like on the manufacturing side, owning small the devices. And also we're talking about Tecodia defined as a reliability requirement, but what we really found out that is not sufficient to cover actual deployment of the requirement. And then another problem is that when you define the process, which you can make very beautiful engineering devices, versus actually on the manufacturing side, when you hit in the big ramp up, what kind of problem you're going to face it. So that is like the two different kind of problems. And then associated with how the infant mortality issues is causing us the problem. That is the reason I was asking about MTBF, how you estimate your MTBF for any devices, as well as you during your manufacturing process, how you can make the bus top, on the bottom. So that is going to be we're going to discuss very briefly in this presentation. So this is like 100 gig optics is what I was driving at Facebook from like almost 4 years ago. This 100 gig ZWDM technology was starting like probably 4 or 5 years ago, starting to deploy it. Right now, Facebook we're using probably millions of the unit every year. So it's a huge volumes of the product. And then what we are seeing the problem is that the DOA. Majority of the problem is like the data on arrival, which means is after your devices you plug on, power on, within 1 month, you have failures. So most of the hour of the failures are happening on the DOA. If you digested what kind of failures of the signature it could be, and I think along this failures, 97% of the failure is laser. It's nothing to do with any photo detectors, nothing to do with the IC, but it's laser is critical. So if I dive in that path more detailedly, and what I found out is that currently most of the people is doing fabrication like the indium phosphide, which is a laser is using in data center for single mode laser. And then what they happen is that they fabrication of the laser, but they fully utilize, so we call it the burning process to figure it out what kind of the failure of the could be. And then we found out that is not sufficient enough. And that currently we are doing it. I think the industry is really depends on the burning to screen out all the potential the defects come out from the wafer. But I don't think that is necessary. It's only the solution we're going to have it. So another thing, if we look at the feed number, feed means is the feed in time. That is meaning is that if you have a feed number is 1, which means you have 1 failures out of 1 billion of devices on the operation hours. So that is like a standard quality of the matrix using to describe how good of the quality it is of the product. And then if you divide it into the laser, as I mentioned that we have a lot of failures from laser, almost 100% of the failures coming from laser. If you divide it into the laser into the different category, one is called the DML laser, another is called the EML laser. DML meaning it's a directed modulator laser. And then EML laser is basically using like an external cavity or using like the electron absorption, some modulation. Or in the silicon photonics, you're using like the continuous mode of the laser. And then you can see the failure pattern is huge differences. On this slide, on this figure, you can see DML laser overall, over our 2 or 3 years of the data, we're showing like 2,000 of the feed numbers, which means you have 1 billion operation devices hours, you have 2,000 failure event. And then meanwhile, silicon photonics, where the CW, like the continuous mode laser, as well as the EML laser combined is a single digit. So you can see the huge differences. And then the reason, if you dive into what is the differences, I think it is because of the burning process. It's not sufficient enough to cover all the failures. So that is the problem statement. And I want to share you, this is a Facebook's data center. Currently, globally, we have 15 data centers globally. And then we have using millions of the optics. So which means when we're starting to identify certain technology, which is going to be used in our data center application. And then the real application was starting like probably like within 1 year. And then when we're starting to quantify certain product versus we actually deploy, the number can be starting from 100 the devices to millions of devices within 1 year. So that is bring us a huge challenges to working with a different supplier, how can ramp up their production. And then considering this, the quality concern, reliability concern, that is a really huge challenges. I think that this challenge is going to be continued if the next generation of the technology is going to deploy it. So every people knows about the bus stop, right? And then what we are really saying is that if you laser burning optimization actually is happening in the infant mortality on the earlier phases. Normally, if your factory have a very good screening process, you are keeping the blue line where you keeping this area is in your production, and then keep this product into the field, which you have constant, very low constant failure. And then after the 5 years or 6 years, you have wear out the failure. So that is no problem. But I think that currently we are facing is about the laser, especially for the laser burning optimization. It's not very well defined. That is where you causing this, the blue line shifted to the pink line, where we are seeing a lot of failures on the laser. So that is the problem we are seeing from end user perspective. We are seeing, so we want to address this issue to the whole industry. And then, so practical approaches is that you have an overall, like what are we talking about, the FTBM, MTBF versus like the feed numbers we're talking about for the optical devices. And we have talking about like the annual failure rate as well. Is one of the, the key metrics that control the parameters. And then obviously the Takeodia standard is one of the things which we want to use it to follow. Actually, right now I'm trying to initiative to for the photonics industry together with the data center, and then try to seek one of the reliability requirement for the whole industry accepted by manufacturer as well as the data center as well. So before, the optical devices are using in the telecom, normally the lifetime is designed for 25 years. But I think for data center, we only use 5+ years, a maximum probably 6 years. And then that is like, it's going to be changing the requirement in terms of the reliability and the quality control. And then another thing I want to see is we don't want to trade off between reliability and the network redundancy. That is definitely, so as I mentioned earlier, any failures in the data center is a huge the deal. It's not a trivial deal anymore. So I think along this years, I also working with a different supplier to using enhanced ongoing reliability testing to make sure the devices is well controlled in their manufacturing process. So the reason I'm bringing these topics here is that I want to share as an end user what we learn from photonics the devices, and also I wish this the lessons we learn can be shared by the industry, so industry can improve the product in terms of the reliability and the quality. So this is a very famous Facebook the slogan. The January is 1% finished. So that is my presentation. Thank you so much.
Thank you very much for being with us this afternoon. Thank you for this great presentation. You said your first ever EPIC meeting. I think it's not the last one. I think we're going to be knocking on your door, seeing this user perspective. This is how it works. You told us what you can do for the supply chain. That was very clear. So I want you to challenge us. If you could find the ideal partner out of this meeting, or at least out of this network of 500 companies, what would be that partner?
Yeah, what I'm saying is that I've been working for photonics industry since probably 1990s, and then after that I'm working for industry and now working for the data center. So what I'm seeing from photonics industry, photonics industry is really have a lot of talented people. There's no doubt about it. Very branding idea, very, very great idea. But I think it's a really lack of the design for manufacturing of the mindset. So you can build in some devices with very bright features, but few people is really considering the volume. Really few people really considering if you build these devices in this design, whether you can make in 10,000, 100,000, million units per year within a very short time. So design for manufacturing actually is a very weak area generally for photonics industry. That is what I really take. I really wish our photonics growing, because if you look at the the IC technology back to 1940, right? So it's a individual transistor, and then everything is, and then we merge it to the IC. There's several things happen. One is the user, different area. Before, like a transistor only the radio, right? And then optical is coming, and then you can see all transmitter, transceiver, this kind of thing. But I think the LIDAR is bring a huge territory for photonics, where you can, extend it as a photonics, the application area. So this is very good. And then second one, the manufacturing side, we need to really think about, if you want to bring the volume going to high, the user is going to be high, and then you need to make sure your devices is reliable, high quality.
2 days ago, we had an online meeting on photonics beyond 400G, and we talked about the Telcordia standard. I am particularly not crazy about that one, but I'm very crazy of what you said about design for manufacturing. One of our key members in EPIC is JENOPTIK, enabling companies to go into that volume. Simon, thank you very much for being with us this afternoon.
Okay, yeah.
Simon, do you have a question for Vince?
Yes, I'm kind of surprised to hear that kind of talk in the LIDAR meeting, but it's very exciting. So thank you, Vincent, for sharing your insight. I don't know if you have heard of Jabil. Jabil's only looking into high volume businesses. So we are specifically taking, let's say, engineered products to high volume manufacturing. And we have a specific group within Jabil. It's called Jabil Photonics, by accident. And these guys are, let's say, active in the field that you just described. So I'm just in parallel reaching out to them so that you can connect after the meeting.
In our network in EPIC, JENOPTIK plays this role in which we help companies that develop photonic integrated circuits into going to the ultra high volume production. So they validate the design for manufacturing, and they have a huge activity on silicon photonics. But also in EPIC, we have indium phosphide. They have a foundry in Eindhoven, Smart Photonics. Thank you very much for joining us this afternoon from beautiful Eindhoven, Rock City. What does Smart Photonics do, and how can you help Facebook?
Well, actually, I was, well, firstly, thank you for your talk. It was very interesting, but I was surprised to hear of the high burn rate. I definitely would like to check in with you later on, if that's okay, to see what's causing it, because that's definitely surprising based on some of the feedback that I'm getting. We are also in the industry working with some of the telecom companies indirectly. We work with OEMs, and that's definitely not the kind of feedback we are getting from them.
I think I think that what I try to present here is a very fundamental issues we're seeing it. The 97% of the failure is from laser is true statement. Actually, right now we are seeing more and more of the problem from laser as well. So not saying that is so like the failure, we have like the threshold for any failure of the devices. By saying that, it's not saying that the old optical devices is really bad. I don't say that. I think the overall, the optical performance, actually, we can keep the MTBF is about 500,000 hours. I think it's about the right statement. But if we're solving the laser related to the failure, I believe the photonics, like the optical transceiver, the feed number will be single digit. MTBF will be super like millions of the hours, which means transceiver, if we're treating a transceiver as IC devices, and then if we're solving the lasers problem, then the transceiver actually can be high qualified as an iPhone, I would say. So if we're solving the lasers problem, photonic devices will be good. And that is actually my eye is looking for next generation, like beyond 400 gig, what kind of a co-packaged devices or onboard optics devices could be, because when we're looking on that directions, a lot of things are going to happen integrated together. So it's a problem is not only from the laser, but from the integration process itself, as well as the IC. So that is will bring a lot of a complexity of the problem. But if we do understand the problem individually, and then we'll be able to handle multiple problems together.
I have somebody else I want you to be introduced to, a company in Northern Ireland, Yellow. Dylan Bork is here with us, and Dylan has placed Yellow as the company in our network to do the volume testing of different integrated photonic solutions. Dylan, thank you for joining us this afternoon from beautiful Belfast.
Hi, Jose. How are you? Got your favorite one here.
Yeah, well, I have one from BLC Photonics today. What can Yellow do for Facebook?
Yeah, Vincent, thanks for your talk. Yeah, as you know, we are, I don't know if you've heard of us, but we are a manufacturer.
Yes, we do. A lot of our supply actually using your devices.
Well, that's good. That's a good sign.
Yeah.
Yeah, as I said, we've been going for 30 years. We manufacture laser diode burn-in live test equipment. We're always very happy to have a conversation. And it was a very important point that you hit on earlier about designing for volume manufacturing. It's a very important point, and we always like to encourage anyone who's considering burn-in live test to speak to us during that design phase of their device, so we can help in that area. Absolutely.
Definitely, yeah.
Any further question for Vincent? For Facebook, not every day you get the chance of asking Facebook about the need for reliability of your photonic devices. We're going to have a discussion later, but Vince, you have made my afternoon for being here with us. Thank you so much for your presence here. I think we have a lot to do together in our activities on packaging, high volume packaging of photonic integrated circuits. One more thing is mentioned here behind, I don't know if you can see it, Speaks Up. We are bringing the whole worldwide packaging solutions to offer volume production of packaging silicon photonics, indium phosphide, and triplex. It is great to have you as the real end user. Congratulations on your network. Congratulations on being on this network today. And we continue with the program, and the next presentation is from Peggy Dietrich. She's coming from JENOPTIK. The capital of optics in Europe is Jena, and JENOPTIK is represented by Peggy today, and she's going to tell us how we can work together. Peggy, thank you very much for being with us this afternoon. Hello, can we hear you? Hello, thank you very much for being with us this afternoon. The floor, the attention of everyone in the world is yours.
Thank you very much. Hello, everybody outside in the world. Today, I would like to let you know a bit what LIDAR technology JENOPTIK could offer. May a lot of you heard already that JENOPTIK is since a couple of years in the business of LIDAR technology when you think about one-dimensional one. But also in this presentation, we will focus on one of the three divisions JENOPTIK has, is more the light and optics division. The focus fields are optics, laser technology, digital imaging, optoelectronics, and sensors. And therefore, we have 28 years of experience in developing and manufacturing about photonic solutions in general. We also are using cutting-edge technology base, and we also have worldwide subsidiaries available. But today, the topic will be the LIDAR technology. Some couple of you heard about from us since 2 years. There we had the approach that we were focused to develop a prototype in 3D lighting with MEMS technology. But nowadays, and through our restructuring, JENOPTIK will focus on different areas anymore. The part is not anymore to develop our own LIDAR system, as Roches mentioned in his beginning, in his presentations, where he is located JENOPTIK as a LIDAR manufacturer in general. This was our starting point, and now we changed our strategy approach a bit. And therefore, you can see here in the automotive part, the signal chain, so which has the LIDAR model principles here. You have the emitting lights, where also a lot of colleagues of you talked about vessels, laser diodes, then the pulse light that you can bring the right impulse out, that you can detect it, the different ways of steering lights. Then also you have the shape light. It's the part where you bring the light in the form which you need or the field of view you want, like over aspherical elements, diffractive optical elements, micro lens arrays, which you need more when you have the principle for a flashlight with vessels, for example. And also you have different filters for the sensors, the nanostructure, mirror coating, anti-reflect and Brent filter coating, and also the filtering light and shape light components you have as well on the receiver element in a LiDAR system. And therefore is also, for example, with Brent filter coating, you want only that you get back the signal or the wavelengths you emit. Because when you think about your eyes and you drive your car, it's also that you have the sunlight goes down, then also we normal people don't really see something on the streets. And this also could happen with a LiDAR system, for example. Yeah, and therefore, as you can see on the picture, when you see the automotive value chain, we offer only some components, especially when you think about the presentation of LeddarTech. He said he's very interested in component fronts, for example. Therefore, JENOPTIK could be a partner in different fields. Yeah, for the sender parts like shape lights or also filtering lights. And also we are focusing us on submodule business where we put emitting light and pulse light together, or also components like receiver channel with polymer optics and injection molding parts, and also with different filters on it, what we can produce as well in a short prototype series, but also there with the fields of shape and filter light and our polymer injection molding know-how, we're also able to do a mass production, for example. Yeah. So what it's a part what the JENOPTIK can offer, and what we are looking for in this part. We are interested in parts which are interesting to improve the LiDAR system with our know-how, what you saw in the slide before, and also with our polymer injection molding know-how. Therefore, for example, we could produce aspheric lenses. This depends on the design of the optics, that we could reach peak of valley under 1 micrometer or a micro roughness under 10 nanometer, for example. And as well, we also are really good in micro lens arrays when somebody want to achieve a flashlight system with vector systems, that you get a similar beam and an homogeneous beam. Then also we have a really high precision in sub-micro ranges. And also the part is we are able to produce both sides micro lens arrays. And as well, we have a lot of technical know-how in diffractive optical elements. So therefore, we're looking for people, they need as well some engineering, consulting partner for their LiDAR system, how to shape the light, for example. Yeah, and then also to help them as well to make the production for it on a big part. Thank you very much to all.
Thank you so much, Peggy. It was a really nice talk. And JENOPTIK is a unique partner for LiDAR technology because you cover the part from the dyed laser to the optics to the sensors, and that's what makes this company very unique. Does anybody have a question? Julian.
Yes, I have a question. Thank you. You mentioned that you're doing optics based on polymer. And before we heard about reliability, how it's a big topic, even more for LiDAR, I would expect, because it's life critical. So how is the polymer that you're using compatible with the environmental requirements of LiDAR systems?
The polymers are, it depends every time on which part in the LiDAR system the polymer is located, of course, yeah. But as well, when you think about cover glasses for a LiDAR system, for example, we're also able to put heating systems inside to the polymer as well, that you can heat it so that you wouldn't have not a real issue with freezing outside and stuff, because this is also a huge requirement for the automotive industry, as we know from other conferences. And as well, polymer is, of course, with a high temperature over 125 degrees, then of course the polymer material is not really good solution. But also when you think about the requirements, a lot of automotive car makers said to their LiDAR system that they said, okay, minus 40 degrees to 70 degrees. Then with this, of course, polymer optics could fit as well as a solution. And the part is as well, they are more cheaper than glass optics, for example. And as well, they also lightweight. And also with polymer, you do not need a huge optical systems out of 8 lenses, for example, to shape the light in the direction as you want, or for the field of view. Sometimes you also can use a different part. And as well, you have the opportunity to combine as well optic and electronics adherent optic together, also with the injection molding sometimes. This is also a unique advantage from us.
Thank you.
Thank you so much. Is there another question?
I am having a question to you, Peggy. Do you have any idea about LIDT measurements, LIDT results those polymers need to bear?
This is Andrea from Delo.
Oh, sorry, yeah.
What do you mean with LIDTE? Sorry, when I do not know each.
No problem. Because I mean, we are developing optical material, UV curing polymers for micro lens arrays, for micro lenses, based on imprint process or others. It doesn't care. And we are more and more asked by customers, okay, what is your LIDT? Which experience do you have with your polymers, with your materials regarding LIDT measurements? Do you have results? Do you see those requirements coming, or do you have any experience in this field?
Therefore, I have to get a question with me and have to ask my colleagues, of course. Yeah.
Okay.
But what I can say is when we do optical development, or when a customer comes and want only a build to print, for us is every time important that what he wants and which the design, that we can measure all important parts. Yeah, this is important also for the polymer part when you want to produce it, that you can measure everything, and also may it relates to the LITD. Yeah, but therefore I have definitely to take the question with me. And may you also feel free to write me an email, and then I will definitely help you to give you the answer.
Perfect, thank you.
Very nice. And I also heard you speaking about shaping of the beam and software for that. And I'm very happy that the next speaker will be LeddarTech for optical software. And we have René.
Yes, Födisch from LeddarTech. Hello.
Hi,
I hope
Rainer.
you can hear me. I have to share my screen.
Yes, we do.
Do you see something right now?
Yes, we do. Please go to the presentation mode and
Good.
we can start there.
Okay, so my name is Födisch from the company LeddarTech. So thank you, Jose, for the invitation. Thank you, EPIC, for everything, making this happen. This is nice. Normally, we want to have face-to-face meetings with customers, with the EPIC members, but this time online. But online is also not a bad idea. So what is LeddarTech doing? So LeddarTech is providing optical design software packages from the company JENOPTIK. So we are dealing with Code 5 as an imaging optical design software, light tools, illumination design software, our software micro nano photonics, and also lucid shape for automotive application, more in the illumination area if you are creating a front lamp or a rear lamp. Also, we are providing measurement surface, or surface measurements, that is giving us information about the reflectivity, about the scattering of a surface. That is very important for LiDAR development. And we are measuring this surface. And also we are creating and we are developing measurement instruments for these tasks. And another thing is what we are offering. We are training people in our software devices, and also we are providing engineering tasks in different fields of illumination optics and imaging optics. What has this something to do with LiDAR? I mean, and I want to talk here a little bit more about Code 5 and light tools, because that are the main tools for us in the field of LiDAR developments. If we are talking about optical let's say, optical design, illumination design of a LiDAR system. So we have two different, yeah, let's say, software tools. So this is Code 5 and this is Light tools. And we have seen so much increase in the LiDAR world that we have more and more requests from all these LiDAR manufacturers saying, I mean, what can your software do for us? And first of all, Code 5 is excellent designing software or design software for all the imaging tasks in a LiDAR system. Let's say if you are designing the laser beam optics that is shaping the laser beam towards the car or towards the environment. The scanning system maybe is also designed in an imaging driven software package. And of course, the laser launch optics and the detector optics is important. You see here on the right-hand side some other applications we are normally providing with Code 5, or Code 5 is covering all this information. Also, the Hubble repair mission was, for instance, designed with the team of the Code 5 developers or in Code 5 as well. Light tools is a different kind of tool. We are talking about light tools as a complete measurement. I get an inside call. This is very annoying. But we are using light tools really for all the interesting behavior about the light that is reflected from a car that goes back to the detector, and what about all the environmental behaviors, atmospheric behaviors that decreases your LiDAR signal. How is this modeled? I mean, for all the software packages, I mean, you have to specify, let's say, in which field you are using the software. First of all, Code 5, you are dealing with the imaging software. Light tools more with the complete system. Huh? So how is a LiDAR system look like? You are much more familiar on this like I do, because I'm just a software user. But what you can see is we have a laser-driven light source, or a laser-driven light source. All this light source goes through a laser launch optic. We have a mirror inside the system, and then we have a MEMS mirror that is very, very fast in tilting the light towards, for instance, the car to detect the distance. And of course, we have a detector system to catch the light that is reflected back by a car in front of you. Everything is, of course, made in a housing. And important to know is that we are talking here about a spinning body LiDAR system. So this is just as an example. So if you are talking about the image optics of the launch system, of a laser launch system, here we are using a 4-layer laser diode system. Then we have 4 elements, let's say optic, that is designed or can be designed in Code 5. In our case, of course, Code 5. Then we can transfer everything in light tools, and also you see the light distribution that comes out of it. So these are the important thing what you can do. And the beam shaping of the laser created in Code 5 and later transferred into light tools to make it visible. The detector system looks a little bit different. You can only see a big lens, and on the right-hand side, you see a small chip. We are normally used here for this presentation. We were using a 8-pins avalanche photodiode that is enough to detect the light here. However, we have to catch as much as we can on the light. So that's why it's a really fast system here. A couple of lenses. It's not too simple, but it's not designed to have a really, really super sharp lens, because we just detect if this light on the avalanche photodiode or not. So this is important. However, the system is kind of fast. It's huge compared to the sensor, and we want to catch here a lot of light with the system. In the software light tools, you see then the behavior of the system. Everything is parameterized. You see the light on the street. You see the light, the reflection on the car. Light is transferred back, and we are measuring the distance here between the rings. You see these 2 rings. This is just an indication of the 1 meter distance, and we are calculating here, or we are measuring here the time of flight by optical path length filter. So we do not want to see all the light in our system. We only want to catch the light that is important for us, and that's why we are using special filters here. Here also another picture to see how many spots are on the car. I mean, just for visualization. So normally you just have one spot, but this is just a scan over the car on the street where you see the light is reflected. So filtering of the time of flight light, this is important. So in Light Tools, this is the illumination design software package. We are creating special filters, and here in this case, a minimal optical path length filters and a maximum optical path length filter. And the detector is only catching the light in a specific range here in 19.2 meters. And the maximum is here 21 meters, and in this range the light gets detected. Also, we have a source filter, and we can make a combination between all this filter stuff, and then you can really calculate your light on your detector. A very nice thing, an important thing in my point of view, is that if you are working in Light Tools, you would like to investigate also atmospheric effects. What about fog? What about the behavior of rain droplets between the LiDAR system and the car in front of you? I mean, this is a thing you can investigate in Light Tools very nicely, and you are just calculating here a box. This is here this purple box, and inside the purple box is air. We are filling this with air, and inside the box is also rain droplets or fog droplets. And depending on the size of the droplets, we can use mean theory or other theories to have, let's say, a volume scattering effect inside this volume, and then we see here effect on your signal. So what you can see is here the signal, the signal strains towards the length of the distance. I mean, between 0 and 200 meters. And what you can see is the first one is here air only, and you see almost no influence, of course. But if you compare this with light rain or medium rain or even heavy rain, there's almost no degrees of signal strange. I mean, of course, the longer the way gets, I mean, you see a certain signal drop, but the effect is very, very small compared to air only. And only moderate fog has a larger influence on your signal. And you can see this here. And such things can be investigated in Light Tools very nicely. That is also, that should also conclude here my talk. And what we expect from customers is, or customers who are working maybe in different kind of software packages, what is important for you? I mean, what is important? What are you expecting from your software to deliver? I mean, can you describe the laser correctly? Can you describe the fog correctly if you're making such atmospheric investigations? And these are really, really nice questions we are interested in. And if you have a questions, please let me know. And yeah.
Thank you very much, Rainier. Thank you for a great presentation. At the end of the day, LeddarTech is positioned in EPIC for providing software solution, but also assistance with design, and also the manufacture certain system-based prototypes in optics. So it is great to have you in this event. Quickly, because you didn't really respect the time. So quickly, what can you do for them and what can they do for you?
So, I mean, we are providing the software that can fulfill your, let's say, simulation needs. If you are talking about optical simulations and imaging simulations, imaging design of the detector system or the laser launch system, and of course, all those atmospheric effects in Light Tools, for instance. Another effect is stray light. I mean, you will have to calculate all the stray light around your systems, and you need to know where it's coming from, and you need to design some countermeasures to get rid of it. So that is a thing we can deliver in a software. We call it virtual prototyping instead of trial and error in a laboratory. So make everything in a software, or the things you can do in a software. Not everything can be done in software, but the software covers a lot. And another thing is what we are providing. We are providing the software trainings, and of course, all this, let's say, question answer support for software you will need to use the software successfully. This is the most important thing.
At Epic now we have lots of end users. I'm very happy that this was my contribution to Epic. It used to be a technology, very flat organization with components, but now we go all the way to system integrators and end users. I want you to meet one of them. Chris Dawson is here representing MBDA. When it comes to the aerospace, LIDAR technologies have attracted already for many years a lot of interest, but now I have seen very hot topics being acknowledged by MBDA for the next generation LIDAR. Why did you come to this meeting, and what kind of partnerships would be interesting for MBDA on this particular field?
Hi, yeah, thank you for having us. Just to give some background to those guys that don't know, so MBDA are MBDA missile systems. So we're across European country. We manufacture missiles and missile systems for many of the governments in Western Europe. So in terms of LIDAR, for us, this is something we've been looking at for quite a while. But like you say, it's come to the fore in the last. So as far as what we're after, we basically are after being an end user. So we're after subcomponents and subsystems. That can be both software. So like we've just seen, actually, that's kind of software packages like that are very useful to us, being able to simulate what we'd see in the different environmental conditions, etc. But also the optical components. So things like detectors, the sources, beam steering, the various different optical subsystems that exist in a LiDAR system. We're interested in that.
What I have discussed with many of your colleagues in the past is the field of view. Basically, you have been always telling me that 120 degrees is really the magic number. Is that correct also from your point of view? Is 120 degrees the field of view ideal for the applications that you target?
Not necessarily, no. There's a couple of different kind of regimes. So 120 degrees is what we would call a field of regard. So the accessible region. We're looking way down much further at narrow fields of view. So probably more around 5 degrees for a very narrow field of view. So it depends on the type of system, but a lot of our systems, because they're going very fast and they're much more directionally stable than something like a car for automotive LiDAR, we'd be looking at very narrow fields of view. So much longer ranges, but very narrow fields of view. And then in other systems, it can vary. So most of them are this narrow field of view, but some can be out to as wide as something like 120 degrees. But that would kind of probably be with a secondary beam steering system. So
for the customization of the field of view in combination with the light source, I cannot see a better partner than LeddarTech for you to have a conversation offline in order to make the right optical design. But I also, Chris, one of the challenges that we discussed in the past is not only about the light source, not only about the field of view, but also about how to keep the light collimated in the long range. Could you also specify that particular challenge for the supply chain?
Yeah. So like I was saying, our use case is probably a lot longer range than most use cases for LiDAR. So we're looking out to maybe 1,000 meters. That's the kind of ballpark that we'd like to be having very good performance in. So good collimation is key, and then a system that has good performance with regards to scattering, both in the atmospheric, off particulates in the air, and off things like fog and rain. So we need to be able to work in all weather conditions. Out to very long ranges. So yeah, collimation is very important.
Pierre, Chris, whenever you're looking for high-end optics, we have a company in Epic, in Jena, in the capital of optics again, Aspheric. Angela, thank you very much for being with us this afternoon. So far, what did you learn about this meeting, and which kind of cooperation do you think you can provide your amazing company?
Yeah, so I learned that there are a lot of different wavelengths used. So I cannot distinguish what is the general LiDAR wavelength. So we also provide optical filters, sputtering or evaporation filters, something like this maybe. And of course, aspheric lenses and freeform lenses we can contribute with for the optical path.
Pierre, I keep getting this question from many of our laser manufacturing companies. Like, for example, we have Modulite in Finland, and they keep also asking us this question. Pierre, from LeddarTech, what is the magic wavelength that is going to win the LiDAR battle?
There's no magic, because they're all compromises. Certainly lower wavelengths are nice because they work with silicon. but certainly it depends on what the best compromise is. 940 as the gentleman from Ibeo was mentioning is nice because there's sort of a notch in the solar noise, but in the end it's a matter of compromise and you deal with what you have to. But certainly 940 is a nice wavelength, that's for certain.
Because Vince from Facebook, he was talking constantly about photonic integrated circuits, indium phosphide, silicon photonics. Those operate at the telecom wavelengths, 1.55 micrometer, 1.3, which is very good for eye safety. But does LeddarTech consider these longer wavelengths as well?
Yeah, but in the end, I mean, we're unfortunately automotive LIDAR is not working with telecom budgets. So if we need to meet the less than $100 cost point that the industry wants, certainly silicon as a huge head start.
Olaf from JENOPTIK, thank you very much for joining the meeting. JENOPTIK has been quite active in EPIC on providing light sources from very different applications. When it comes to LIDAR, what kind of wavelengths are the targeted one by JENOPTIK?
I can probably pass on this information, this question to my colleague who is on the call as well. It's Achim Greiner from Excellitas, because the Excellitas part provides the LIDAR.
Yes, hi.
Hi,
can you hear me?
Yes.
Okay, good. So, well, actually, I mean, we are a component manufacturer or a sub-assembly manufacturer. So we are most of the time open to the requirements from our customers, obviously. However, I mean, I can only confirm what Julian said, that 1550, I think, although some people say that long-range LiDAR will not work with silicon and 905, 1550 seems a bit out of range in terms of pricing. However, eye safety is obviously important. You need, in order to get the range, you need more power. So, also, it's another wavelength that has been mentioned here. 940 nanometers might be a winner in the future. So we are working on that wavelength, and it offers, let's say, it offers advantages of pricing plus performance. So I think that's maybe a very good solution for the future.
We also have the presence. I know we have a question from Julian from 26. Julian.
Thank you. I wanted to bounce on that because I understand the benefit of 940 to reject the ambient sunlight because of the absorption in the atmosphere. But I would like to ask the users, is it not a problem then that the signal of the LiDAR, if you use 940 illumination, would also get absorbed by the humidity in the air? So if you have fog, if you have rain, isn't that a problem? Wouldn't you prefer another wavelength then?
Ünsal.
Okay, so so there will be definitely an absorption in the atmosphere, and but at the end it's everything a compromise. So what to achieve at which costs, and 940 also for us seems to be promising. If we look on the dense fog situations like visibilities at low range, so below 50 meters. Then at the end, it doesn't matter in which wavelengths you want to operate. They have all the same bad performance. So the physics, you cannot overcome the physics at this place.
I think we had a fantastic debate. That's what I call epic. I really enjoy this part of the work. So thank you for this. And we continue with the program and we go to Belgium. We go to imec. Perhaps my favorite R&D EPIC member. Thank you for being with us, Marcus. Marcus is one of the top people that we have when it comes to bringing silicon photonics and LiDAR together. Thank you, and telling us how we can help you develop the imec dreams in LiDAR.
Okay, thank you. Thank you so much, Jose and EPIC, for the invitation. Can you hear me well? Okay, let me share the screen. I'll tell you a little bit at the end how we can interact with you, or what we're looking for you and what we can also offer you. So let me see. So my talk today, and I did participate in the last EPIC meeting in October in Eindhoven. So what I'm showing you today is actually some recent work that we did since October until recently. So this is very fresh results, and I'm very proud to show this here. And obviously this is part of a big team, but the talk is on photonic integrated circuits for LIDAR, and in particular solid state 2D beam steering. So just if you don't know, or if you never heard about imec, I just have a brief slide here to tell you that imec has been around for over 35 years. And we have invested largely in an infrastructure that has led us to actually become one of the world R&D centers in Europe for nanotechnology, nanoelectronics, etc. Part of that infrastructure are two large 24/7 operation clean rooms where we can process 200 and 300 millimeter wafers. We have over all these years worked with over 600 companies, from small startups all the way to very, very large companies. We operate with a very large research budget, and we have about 4,000 researchers, most of them located in our headquarters in Leuven. The work that I'll be showing you here is pretty much based on two well-developed platforms that we have established at imec. The first one is a silicon photonics platform, and this one was initially developed for the telecom industry, as somebody mentioned, and therefore I'm showing you here some of the typical devices, including modulators and photodetectors, high-speed devices that you would use in telecom, silicon photonics telecom devices. Obviously, we are reusing this to build components for LIDAR. On top of this platform, we have a very mature also silicon nitride photonics platform, which was initially developed for biophotonics, biosensing, etc. And as you know, we're talking about wavelengths here that could go all the way down to the visible in wavelength. So with these two platforms, we can pretty much cover anything from visible all the way up to O and C band. Showing you here just the basic general building blocks of a LiDAR. This is a very simplified version or a way to look at it. But what I wanted to say is that there's a few set of components that fit in a photonic integrated circuit. And obviously there's a lot of control and processing that would fit into an ASIC. And ideally, at some point, you will be able to build all these components into the same photonic integrated circuit. And obviously, we are working on several of these components that you can see here. But today, my focus is on this optical phased array, which is a solid state solution to delivering the beam and to receiving the beam as well through two different ones, or even through the same one if you use a circulator in this approach. And there's a lot of general target specs that you could or that you may want, that the industry may want for the automotive. I'm not going to go over all of these. Some people have talked about different specs. I just wanted to point out that when it comes to field of view, our understanding is that in the horizontal, anything from 30 to 100, this obviously depends on the application. In the vertical, 10 to 30, and that is pretty much shown here, horizontal and vertical field of view. The way we actually scan through this field of view is, as I mentioned, with an optical phase array. And this particular demonstration happens at 1550 nanometers. Having said this, we are sort of agnostic to the wavelength that you decide to use, as well as the engine, the detection engine that you decide to use. Most people, or traditionally people, have been using time of flight engines, but FMCW is also a very interesting technique, which would work actually very well at wavelengths in the O and the C band, so 1310 and 1550. And a phased array has been around for decades in the RF domain, and many people are very familiar with what they are. It's essentially an array of emitting elements spaced by a distance d, where each antenna is fed with a differential phase shift delta phi. Okay, so if you do this, here I'm assuming that the amplitude is the same, but the amplitude can obviously also be changed. So if you look then in the far field as a function of this angle, what you see is an interference pattern that shows normally a main lobe, some grading lobes, some side lobes. And this is, if you're familiar with this, is simply the multiplication of what we call the array factor, which depends on the distance and the location of the antennas, by the antenna, the element factor, which is depends on the design of each individual antenna. And as you feed and change this differential phase shift, you're steering your beam in this direction, which is shown in this illustration here. So simply by changing the phase here, you are steering your beam in one direction, this alpha direction. Okay, so we use that idea or that approach to steer the beam, and I'm showing you here a photonic chip to steer the beam in this horizontal direction. Okay, so this horizontal direction is achieved by tuning the phase shift between each one of the antennas, and we do so in this particular case through some thermal phase shifters using the thermal optic coefficient. The second direction, the vertical direction, is achieved through tuning the wavelength of our laser source. And the reason is because each one of these small antennas is based on a grating, and that grating will have an angle of emission, which depends among others on the wavelength. And what I'm demonstrating here, and these are again some of the very recent results that we have, is a photonic integrated circuit built on silicon and silicon nitride. So it's a hybrid platform. This particular demo has 32 of these elements with a small pitch of 2.5 microns and antenna length of 500. And obviously, the combination of these number of elements, pitch and length, determine your spot size and your field of view. And for this particular demonstration, we have a field of view in the horizontal of 38 degrees, 15 degrees in the vertical. The spot size can be reduced, obviously, if you increase this number of elements. Having said this, obviously, this field of view, which is limited by the antenna pitch, can obviously be increased if you tile several of your photonic chips. So you can reach any combination by tiling these in horizontal or vertical direction. So let me go straight into these results. So if we look at this sort of far field here, which I'm representing here, this is just the image from our imaging system. The dotted lines here are the field of view of our microscope. And what we do is, well, we set first the steering range. As I mentioned, in this particular case, it's 38 degrees, which is determined by the spacing, the pitch between the different elements. As we tune the phase, the differential phase between the different elements between minus pi and 2 pi, sorry, between minus pi and pi, or 0 to 2 pi, we can steer the beam in the horizontal direction. In the vertical direction, we can do something similar by, in this particular case, switching or tuning between 1500 and 1600 nanometers. We can then decide, okay, let's address the following points in our 2D space, and then we can pretty much scan any of these points that we define by tuning the phase and the wavelength. And this is an animation that I hope you can see here. Obviously, you can go to a different set of pattern. In this particular case, I'm just scanning through these lines back and forth, jumping to the next line, etc. But you are obviously not limited to this, and you can scan any pattern that you wish. And I'm also indicating, showing you here, a scan in a zigzag pattern here and in two circles. Okay, so just to quickly summarize, we are working, among others, in 2D beam steering devices, in this particular case, in a hybrid silicon and silicon nitride platform, where the tuning or the steering is achieved through thermal phase shifting in one direction and wavelength tuning in the second direction. Obviously, something I didn't mention in this talk, but phase calibration is essential because you have these tiny waveguides, you will have phase errors. So detecting these phase errors on chip, which we do with on-chip phase, some phase calibration schemes, including integrated photodetectors, we can in real time monitor and correct for these phase errors. And as we talk, we are demonstrating similar steering capabilities with more elements. And so that's something we're working on right now. Another interesting thing is we're also working on 2D lenses using switch matrices and so on. So just wanted to let you know that these optical phase arrays are not the only sort of solid state steering mechanism that we are focusing on. There's still a lot of challenges when it comes to designing these OPAs. Some of them is power consumption, insertion loss, complexity that it becomes when we increase the number of antennas, the tight laser specs, especially if you want to do FMCW, really narrow line with lasers, and of course the integration of all this into the same platform. And these main challenges are driving our research activities in this field, in particular looking at hybrid platforms, not only with silicon and silicon nitride, but potentially with additional materials, looking on how to integrate these 3.5 lasers onto silicon and silicon nitride, looking for packaging solutions, low power phase shifters, and put on chip photo detectors for either for FMCW, LIDAR engine, or for calibration schemes. And the way we operate is that we engage with our clients, with our partners at any level or at any stage, from the simple idea to performing a sort of feasibility study, see what's doable and what's not, all the way to low volume manufacturing that happens in our clean room that operates 24/7. If the company requires high volume manufacturing, we're happy to transfer that process to a foundry, in that way allow you guys to have volume production of your devices. And obviously, what we are looking for in being in participating in these meetings is people that could help some of these topics here, and also to learn what you guys are interested in, because we are here not to compete with any of these LiDAR companies. We're here to provide components and solutions for any of you guys. Thank you.
Thank you so much, Marcus, for this nice talk. As a person who can't drive, I'm totally relying on the outcome of this meeting too, about autonomous automotive industry. And I think your technique now will overcome the constraint power and size budget for that. I think I would like to hear the opinion of our friend Benedetto from Huawei about this meeting and this talk in particular.
Yes, thank you. First of all, very interesting presentations. And so looking at the summary slides from Marcus, I think it's very important to provide a strategy for the co-packaging for co-design of CMOS and electronics. Because for example, for coherent LiDAR, the digital signal processing can facilitate, of course, the detection of signals and the creation of mapping. So I think in addition to the very well developed silicon nitride and silicon platform, the co-design and co-packaging with the electronics would be key, enabling strategy for future generation LiDAR.
This is a very nice point to raise right now. I have to inform you that EPIC is involved with the European pilot lines for silicon packaging for PIC, so photonics integrated circuits. And it's very nice that I have my next speaker now from Smart Photonics to tell us more about that and what you can do.
Well, thank you for that. Right. It's been actually very fascinating listening into some of the conversations. So firstly, thank you, the EPIC team, for putting this together. There's definitely going to be a number of follow-ups I'd like to make with a number of the speakers, but for the sake of the time, I was kind of holding back my comments at the time. I'll start by sharing my talk here. All right.
Yes.
Everyone is able to see what my presentation at this point?
Yeah, we can. It looks beautiful. Just press screen mode and we are ready for action. Great.
Perfect. All right. So my name is Nazanin and I'm with Smart Photonics. We're an indium phosphide foundry based in the Netherlands in Eindhoven. Our production facility is at the high-tech campus, and here at the high-tech campus, we'd like to think of ourselves as the smartest square kilometer in Europe, because we've got a unique and diverse mix of established global brands and research institutes with some of the fast growing enterprises. And I know with the COVID-19 going on, no one wants to hear of anything that's infectious, but there is an indescribable infectious drive that you get by just being at the high-tech campus. All right, so moving on to our background. In terms of our background, our origin is in the 1980s with Philips, but it wasn't until about 2012 that we were founded as an entity. And since then, we've been scaling up. We have a number of world-class state-of-the-art equipment, which obviously not only allows us to push limits of manufacturing possibilities, but it allows us to manufacture in volume, which is something that's very important to a number of the customers we have. We've also been growing in terms of the personnel. We have a very strong development focus, but more than 25% of the company being PhDs alone. And that again is required in this space because we do provide product development and optimization for a number of the industrial users we have across the world. And we have a global coverage in terms of the customers we have, and that's geographically, as well as across fields and sectors. And that's again because of some of the unique capabilities that we have in-house. Probably worth noting that some of our customers are among the Fortune 500 companies. So what do we do? Very simply, we make chips. We make photonic ICs, and these are chips that move light around rather than electrons, and we can integrate a complete system on the chip. So we work with the indium phosphide, the so-called 3.5s, which is a direct band gap that can generate light to make lasers. On our chips, we make light, and we can propagate light. So we make active and passive elements, and you can't do that in silicon, and that's why there's a big advantage with using the indium phosphide platform, which is why we're focusing on that. Indium phosphide is used to produce efficient lasers, sensitive photodetectors, modulators, in wavelength windows. That's very ideal for a number of fields, like telecom. You can reach speeds like never before, datacom, healthcare, aviation, automation, and LIDAR. Specifically, what has brought us together is another area that can greatly benefit from the indium phosphide material. And there's been a number of back and forth in terms of the specific frequency that's ideal and the cost, but the light frequency and the full integration are just a couple of things that I'd like to highlight with regards to indium phosphide platform. So something else about us that I'd like you to remember is that we produce wafers based on customer designs. We are a pure play foundry, which means we don't develop products ourselves. We don't sell products as an OEM. We are independent, and our customers value that because we guard their IP, and that's the beauty of being a pure play foundry. And in fact, if there's nothing else I'd like you to walk away with, it's that Smart Photonics is unique in a sense that we work on indium phosphide platform, not silicon. We are pure play foundry and not linked to any OEM. And we have a commercial manufacturing capability. So it's not just the research institute. So if you're looking to develop products and have volume, we can be a great partner. So we don't have a catalog of products for anyone to pick from. What we have is catalog of design and process building blocks. You can think of it as a toolbox, a set of Lego, if you will. There are virtually unlimited ways that you could combine to manufacture your specific custom circuit. And again, something that's been mentioned earlier, that's not the only thing we do when it comes to manufacturing a product. We make sure it's manufacturable. We take along our customers up the technology readiness and the manufacturing readiness maturity. We get involved at an early stage at the exploratory part. And it could be on a multi-project wafer platform where you can test the design on a wafer with a number of other customers, or you can ask for a specific dedicated run for a dedicated wafer because of the specific set of requirements that you have. But it definitely doesn't end with simply a prototype. We have a process of guiding prototype manufacturing to volume manufacturing of developed products. So I'm going to keep this portion a lot less specific and more looking for feedback. Surely you all know the amount of investment that went into LIDAR in 2019 alone, and they were obviously spent across technologies and systems. So my question for you is, what are your specific requirements? Again, we've heard, specific needs, whether it's 940 or higher up or lower down. But what are you looking for? Obviously, mechanical LIDAR systems are units that are bulkier, and they are going to be costlier as well. Are you interested in truly solid state LIDAR? Are you looking to incorporate optical phase arrays, the FMCWs, and how are you looking to do your design? Are you looking to have it fully integrated? Because having a fully integrated system will obviously make a huge impact on the end cost of your part. There are different approaches, and we're just interested to see what you are looking to do in terms of developing your product. Of course, I'm going to point out to a few different product developments that we've had in the past in different fields. I know there's a lot of text on this slide, and I don't expect you to read any of this, but what I'd like you to pay attention to is just the solutions that we've got in terms of each of these. What you will find is that you're getting higher sensitivity, lower power consumption, higher bandwidths, and these are in orders of magnitude that make significant difference in performance. And obviously, they're also smaller. And again, when you look at the whole unit at the end of the day, they do have lower costs. This is because of the full integration that is possible in the indium phosphide platform. And I think I've referred to it already, that we are also able to do the work on the 1550 nanometer platform, which my personal belief is that it's the future of LIDARs because of the fact that we can produce higher power LIDARs, lasers, and wavelengths that is eye safe compared to some of the lower wavelength platforms.
Thank you very much, Nazanin, for a great presentation. It's very clear the kind of things that we can do for each other. Actually, you summarize it. Can I give you a few seconds to tell us what you can do for them and they can do for you?
Sure. Okay, so I think what makes us unique is that we're indium phosphide, we're pure play, and we can do commercialization of manufacturing, of developed products, sorry. We've got extensive portfolio of some of these high performance design and process building blocks. And we're looking for partners who can take ownership of projects. We're looking for ambitious companies who are looking to collaborate and develop new products in the 1550 nanometer platform.
Thank you. Thank you very much for a great presentation. Let's try to find a few links with the rest of the people. So when it comes to indium phosphide manufacturing, one of the kind of things that you can actually use is integrating detectors, with actually integrated detectors with very high performance. One of the key companies that we have when it comes to provide almost any detector is Hamamatsu, all the way from Japan. I actually went to visit Hamamatsu. It was a great experience. When it comes to detectors for LIDAR, we have you here today from Hamamatsu giving a presentation later, but could I ask you, what kind of materials and what kind of structures are you pushing the most towards the LIDAR market for detectors?
Thanks, Jose. Can I just check everyone can hear me? Yeah.
Yes, we can, loud and clear.
Brilliant. So Hamamatsu, I think what's kind of key to point out, that Hamamatsu uniquely offers detectors over silicon and gas wavelengths. Something that I'll touch on in my presentation. We have considerations for both 905 and 1550 in terms of detectors and light sources. I think just taking all these presentations as a whole, it's clear that with an emerging technology like LIDAR, there'll be different trade-offs and also different requirements based on a different customer's actual key requirements, basically. So to offer a customer, what really is key is offering a full complete package in terms of sensor options, which we provide in terms of the different detectors and also different levels of customization we can offer in terms of the detector package if it is on an array, and what associated electronics we can provide with it as well.
Mm-hmm.
So I think that's
another company that we have very well established in the LiDAR marketing in EPIC is Lumibird, especially from the GeoPsys side. Olivier, thank you very much for being with us this afternoon. We heard already quite a lot of stories from end users, from LiDAR, from laser suppliers, from LiDAR manufacturers. What did you get so far out of this meeting, and what kind of maybe cooperations you foresee to do from your side?
Well, there are different. There are some questions which arose as well, of course, which I would like to ask. I think there are some partners which could be interesting. Mostly we are making laser diodes and fiber lasers, and especially in the field of fiber lasers, we are really at a threshold, and we started already to think a different way to manufacture these kind of sources to be able to fit to the automotive market. And of course, of our all the companies like Smart Photonics, we just talked today, could be interesting for us because we are also interested in integrated photonics and silicon photonics and all these kind of device, which will completely change the way to design and to manufacture fiber lasers. And I heard about one of the difficulties to work at 1550 nanometer is the price. Mm-hmm. And this would be a way to dramatically decrease the price and to be much closer to the diodes. So there are a few participants which could be interesting for us and which we may contact afterwards. Mm-hmm. I had a question regarding this point. Two questions, actually. The people like fiber manufacturing, but not only. For us, one of the difficulties is to know in which direction we have to go, what is required, because we hear a lot about many different technology, FMCW, time-of-flight, flash LiDAR, scanner, and so on and so on. So the difficulty for us is to understand where we have to steer and to target our R&D and the products which are required. Mm-hmm. So my first question, if I may, yes, we'll stop here, is among all these technologies, all the different sources, all the different ways to measure resistance, which one will be used for which application in which field? And my second question is, if you what is the threshold, the cost threshold below which LiDAR manufacturers may consider again a 1550 nanometer source?
You know, I wrote down, let's see how long it takes for us to talk about cost. I have it here written down. It took us 2 hours and 7 minutes. So it's actually quite a good timing for an event on LiDAR. Pierre, when it comes to the use of different LiDAR concepts, we talk about flash LiDAR, we talk about other approaches, and we talk about price. We cannot ask you to make a whole list of all different LiDAR technologies and price, but what is the positioning that LeddarTech is taking towards satisfying the very high demands of the automotive market?
Well, certainly we think there is no one solution that's going to fit all. So trying to have, for example, a very long range, high resolution solution for front facing may require some of these, like, for example, silicon photonics types technologies. But it's going to be cost prohibitive for example, for like around the vehicle for 360-degree cocoon. So we believe in a mix of solutions.
I think for me, the question has to go to Ibeo now. You're a tier one, you provide directly products to the automotive industry. You have to comment on the price versus technology. What have you seen happening from all the different photonic technologies that can enable LIDAR? And are we there yet, offering the low cost, high end products that the industry is demanding?
Yeah, okay, that's a very important question we have here. So one thing we are experiencing in our discussions with OEMs is definitely, yeah, performance, but the second thing is small size and low cost. And in the same time, it has to be reliable. So we are looking at the Facebook talk. So this is something contradicting requirements here. And at the end, so it's automotive. So it has to be low cost. Yeah, so maybe I can say hello to Olivier. So we met each other. So he knows our approach, and we had a very extensive exchange to which direction Lummelbird shall go from our perspective. So.
For me, one more topic I wanted to touch before I introduce the final speaker is the topic of beam delivery. And for that, I have a key company in EPIC, Ophir Spiricon, joining us today. From the point of view of Ophir Spiricon, being able to develop so many good solutions on beam delivery, what did you learn about this meeting so far, and what kind of cooperations, follow-ups you think you can make after this?
Hi, Jose. Hi, everybody. Simon here. So yes, I really enjoyed the meeting. I enjoyed all the presentations. I really loved. I'm the first time actually here in this time. So what the Ophir Spiricon is delivering, we are known because of the laser measurement devices. So what is interesting also in the VCSEL solutions, we are offering some high-speed response multifunctional integrating spheres with fast photodiodes for pulse shape characterizations. And I'm sure this is one topic that could be also really interesting maybe for the next time to go deeper into it. So I really enjoyed it, and I have to say thank you very much for today.
We're going to go now to the last speaker of the session. We go to Scott, we go to Hamamatsu. Thank you very much for staying till the end and send us away the way that we deserve.
Thanks, Jose. Good evening. Yeah, that's later on, isn't it? Good evening, everyone. Thanks for inviting me along today to present. I'm hoping everyone stayed till the end. I realize I am the last speaker, so hopefully everyone's still awake. So I'm just going to try and share my screen, see if this goes well. And let's see if this works.
Perfect.
Let's try.
Yeah, it's working.
Oh, thanks. Right. So on the first slide, yeah. Brilliant. Can everyone see my first slide? Who is Hamamatsu Photonics?
Crystal clear.
Brilliant. So just to touch on the first part, I'm not Loren. My name is Scott. I'm standing in for Loren or Fred. Fred, unfortunately, had another meeting, but I can step in. And so, yeah, the point of why we wanted to be here today, I think I'm not going to read out the slide. I love these slides because it does my job for me. It pretty much puts everything right in front of, or everything what I wanted to say. What particularly highlights on this slide, I think, this hidden champion quote. I think that's particularly key to note. What I've experienced, I've been at Hamamatsu now for about 3 years. And to be honest, it was not a company I was very familiar with when I started. What I've sort of learned in my experience with the industry is Hamamatsu can be very well known in certain circles, particularly stuff like research and medical applications. But for other applications, unluckily for me, it depends how you look at it, it's a challenge. But for myself, my market is automotive, and it's a market where it's somewhat less well known. So what my experience has been is that Hamamatsu has a lot to offer, a lot of companies, but typically, somewhat being a Japanese company, we're not very good at shouting about what we do. So that's my job, basically. So sort of highlights on the slide. We've been around since 1953. It's a long, well-established company. We're very financially secure, probably something that will come out a lot more often in the coming months or years following this COVID situation. We actually reinvest a lot of money back into the company. Around about just under 10% per year goes back into development of new products. So it's a very easy job for myself as a salesperson, because there's always new products coming out to talk about. The nightmare is trying to remember part numbers, because my memory is not the best to start off with. But as you can see there, we have 15,000 products as a comma, not a decimal point. I'd like to point out 15 would not be so something to shout about, depending on what you do. But we have over 15,000 products. This is to give you, so the next slide is to give you an idea of what sort of, don't worry, I'm not going to go through every product, what sort of markets, what sort of stuff we provide into. This again reinforces my point that Hamamatsu provides into a vast array of different markets and applications, but a lot of people would maybe first think of us as maybe a research company with our association with CERN, or in medical fields as well. So I sort of use this like quotation marks, sort of Hamamatsu, we are the biggest photonics company in the world. We're not in terms of employees or in terms of profit, but what we are, the largest photonics company. There's no other photonics company that supplies into as many markets and many different applications as we do. So a lot of our biggest competitors in sort of the medical fields is the likes of like Philips and Siemens, while we're sort of a small, big company. And what I mean by that is having a lot of diverse applicational knowledge feeds back into the company, and it really shows that we're good at what we do based on the fact that our biggest competition in these fields are such much bigger companies. So yeah, these are the most key application markets we supply into, but obviously my main focus is for the automotive industry. Again, this is our products. It's very, if you're familiar with Japanese companies, it's a very Japanese slide. There's a lot of information, information overload everywhere. Particularly for automotive solutions, I think the most key component then is these optical sensors. But we also have the light source in terms of laser products. We also provide ASICs. So uniquely as a LIDAR component supplier, then we manufacture and design all parts of the system, the source detector and the associated circuitry with it, which I think is quite unique as well. One other thing to kind of just highlight, Hamamatsu has 4 main divisions. A component, so a solid state division, electron tubes, systems division, and a laser division. The systems division also, as the name suggests, we manufacture. So for example, in our solid state division, we make image sensor chips, but then we also use them in our cameras that are built in our systems division. One other part is we also make manufacturing support systems, which actually get used in our other divisions to make our own products. But we also develop these for other companies to use in their own manufacturing processes. So not just on the automotive side of the component side supplying into it, but also in the manufacturing method, going straight from wafer dicing all the way down to, or all the way along to failure analysis support systems, checking for defects. So that kind of goes into Vince's point earlier, talking about defects and lifetime. Obviously highly important for automotive customers, one of the biggest drivers apart from cost. So we regularly put this into our products, and it's our own systems that we develop. We also sell to other companies that we use to make our own products. And that was just to kind of touch on sort of what systems we write into this. So we have the failure analysis system, talking about these, talking about the yield of wafers earlier on. We also provide these self-dicing engines for semiconductor wafer processing. So I won't go through these all, but just give an idea of, we don't also just sell components, we can supply into other parts of your production as well. Again, I won't go through this, it's just going to give you a roadmap of what we've been doing as a company, starting off just bare pin photodiodes in our roadmap, excuse the pun, of going towards fully autonomous and LIDAR systems. So what I briefly touched on earlier is that we have different detector options in terms of, we go from pin photodiodes, APDs and SIPMs. And then also what we're developing into is offering detector options at both 905 and 1550. So we've been building upon our silicon PM development from the silicon 905 wavelength, and what we're doing as well is trying to develop in-gas multi-pixel photon counter. That is in the roadmap of our development. And sort of another thing, what we've been doing, sort of you can touch on in this picture very in the middle with the green background, that sort of highlights one thing we're working on is downsizing the footprint of the chip, the sensor. So what we've been doing is you can kind of see in the, the pictures where we're supplying sensors with the circuit, the ASIC implanted on the actual same chip package. I think I've got some pictures of those later on, but one thing that does is that massively downsizes the footprint of the sensor, the associated circuitry with it, the power consumption, and the heat coming off the device as well. So just to throw out another acronym there, because we have so many, MPPC is Hamamatsu's trademark name of silicon PMs. Completely the same technology, it's just to confuse you so we can diverse ourselves to market. One reason is also we're working in these in-gas photomultipliers. You couldn't use a trade name as a SIPM for an in-gas photomultiplier. So one reason why we use the MPPC name, but it's just to let everyone know that it's the same technology as an SIPM. It works on the same principle, same method. So what I briefly mentioned there is this 1D picture. That is silicon PM photomultiplier with the 1x16 detector array, and built on the same chip is then the processing circuit, which is aimed at prioritizing the timing of the detector. That is one dimensional array, and what we're working on now is a 2-dimensional, what they're calling a photon counting image sensor. So similarly, the difference between obviously MPPC, you would get, for an MPPC array, you would get one output, basically surmising all the light that's incident on each pixel. With the 2D image sensor, then you can get individual outputs. So it's obviously a bigger benefit, looking at, there's a lot more detail you're going to get from an image in that sense. And then just kind of briefly go through this just in terms of time, but as I touched on, we do the detector side, we're also offering the source side as well. So this is our newest product that aimed at 905. It's a ceramic package VCSEL, PLD, and we do have VCSELs that are in development. But this PLD, again, it's up to 105 degrees temperature robustness, but we do manufacture all our goods, all our components with the CE qualification in mind. As you understand, with the amount of products that we do, we don't certify each product as they're made, but we make them in a manufacturing process that it would pass these tests. So if you do have a particular component that you look at and it doesn't specifically say that it is AC qualified, all the solid state division basically works on a process where all their automotive components will be developed in a certain way that they will pass this qualification. It's just the amount of time and money that it costs to then qualify them. They won't do it for every single component that they bring out. Again, sort of touched on the other side, so looking at silicon, then at 1550, some of the just getting ready to release is these in-gas photodiode array and APD arrays, which uniquely these have these as our sort of unique secret sauce, where we will call it. There's how they designed the TIA. And I can't also tell you that because I've given away the secret, but that reduces this sort of ringing effect, noise effect in the device, and also the robustness to temperature. So just to summarize kind of what I've put out there, Hamamatsu uniquely have this being the unique position of manufacturing all parts of this LIDAR system in-house, covering detectors, source, and offering complementary circuits as well. We have the reliability in terms of the qualifications already in place, and we also have the capacity in terms of the manufacturing side. I don't want to go on for too much longer. I know I've ran over, but just to kind of highlight one of the points earlier, we were talking about lifetime. So I just stuck this in at the end. This seems like a very kind of relevant graph, and also it's quite a wee bit old, but this was actually by NPL, and they performed a study, this is back in 1985, where they took a lot of sensors from the industry and the market and basically done their own testing to see what the sort of reliability, etc. was. So I'm not going to show you the other sensors that they tested because that would be a bit rude, but for our sensor they tested, they basically took a lifetime of 5 years, 4 years, just to see what sort of degradation there was in terms of sensitivity. And for our sensor, this photodiode, it was pretty much flat over a 40-year lifetime, which, and not to kind of, I'm not obviously going to down talk the competitors, but if you look at the other sort of graphs, it's not exactly a straight line, it's much more of a downward curve, some of them quite a lot steeper. So this is just sort of to reinforce that Hamamatsu work on this principle, a Japanese principle called Kaizen, which effectively means to make better. So this is the process that goes into all of our manufacturing. So I could see that this may be done some time ago, but you can sort of infer from this data that this is how we manufacture our sensors, and this is the sort of process that goes into all our products, not just the photodiodes. And that's me. So thank you. Sorry I ran over there.
Thank you so much, Scott, for the nice talk. You have the advantage of being the last one like that. You have this large overview of all the speakers. Who do your opinion think can collaborate with you? So what kind of collaboration you see already after all these talks with Hamamatsu?
Yeah, I mean, I'm eyeballing, I can see a lot of the speaker names. There's a lot of companies I know we already speak to, different subsidiaries like globally. Yeah, I mean, we're interested in speaking to anyone from the car manufacturers themselves to the LiDAR manufacturers. We want to sort of show what level of customizability we can offer in terms of different detector options or different sources. So we want to speak to, well, not as many people as possible, but basically. I think.
Do you have a question?
Yeah, well, I guess I'm just trying to so I guess from manufacturers of LiDAR systems, what sort of key what sort of questions are your customers asking you in terms of like the technology? Do they want what is the customers coming back with? Do they want, like, say, higher laser power, or do they want more sensitivity? Do they want like lower noise, more temperature robustness? It's just it'd be interesting to see what the customer base, what they're asking for, or what sort of reservation do they have in terms of how the technology is going forward.
Indeed, I think in this meeting we have managed to go through many of these aspects. Actually, what I did while you were all talking and networking and interacting with each other, I took some notes myself. So I was multitasking at the same time. I was running YouTube and I was talking to people in WhatsApp for those telling me to put them in touch with people. So I want to share with you some of my views about this and to see what I got wrong. Let me quickly share my screen with you so we can all see it. So my idea is that, let me take this out of the way. So my idea is that we have been in the beginning discussing about the different wavelengths that we are targeting, different power and different collimation needs. It looks to me that we have still to make a lot of decisions in there, but when I look at the end users and the wavelength that resonated the most there was 940 nanometers. It looks to me that this is going to become perhaps the path towards choosing the wavelength for LiDAR. We are not there yet, and many people are going to push for other solutions. The presentation from Peggy was really exceptional. I got this slide from JENOPTIK in which it showed that there is a lot of flavors to discuss. There is a lot of applications we're going to drive different solutions. That for me is another key point. Is there at the last bullet point. Automotive, aerospace, all of them have completely different specs. LiDAR is not a new technology. It's been alive already for many decades, and actually it is something that is going to be shifting into satisfying different application fields. For me, another learning point today has been the detector side. Also from the presentation from JENOPTIK, which made that a very, very interesting mapping of the different technologies. It was clear that there are different solutions. We talked to Fast3D, we talked to LeddarTech, talked to Ibeo, we talked to NVDA. For me, I'm a big fan of SPADs. I think this is the solution that we had to push, but I don't think we had the maturity level that we need for today. And perhaps the biggest lesson learned was from the presentation on Facebook, and that's my second bullet point in this slide. We talk about the standard for validation, maturation, the standard for reliability of the different components. Many of the people are using the Telcordia standard for the light sources, which is completely, in my opinion, and that's my personal opinion, completely not realistic for this market, especially when it comes to satisfy the cost demands. And in my mind, there is a lot of cooperations available to satisfy all these needs. I'm going to ask now the different end users that we had at the meeting, what they learn about the meeting, what they learn in the meeting, and also what kind of perhaps cooperations, what kind of business opportunities they foresee. I don't want you to tell me which companies you're going to follow up with, of course, but which kind of cooperations you foresee to take over after the meeting. And for that, I'm going to give the floor first to our colleague Chris from NVDA. Chris, what do you think about the meeting, and which kind of companies you think you can follow up after?
So the big takeaway for me has been, something we've been interested in integrated photonics for quite a while, and going forward, that's probably the right direction for us to head. So a big takeaway for me has been some of the integrated photonics companies, and the amount of flexibility there seems to be in terms of just going along and doing the research before you get to this stage of mass manufacture. You know, our business is not one that we are manufacturing 100,000 units. We're manufacturing a few hundred at maximum. So we really need to take advantage where there is the opportunity to go along and do this low volume testing and doing the R&D in these kind of silicon foundries or indium phosphide foundries, and take advantage of that.
Benedetto, from the point of view of Huawei, what has been the key learning points today, and what kind of cooperation do you think you can take over after this?
Well, basically, I've seen a lot of interesting presentation ranging from the photodetector side. So what are the available technology that are enabling the detection of these LiDAR systems? And also what are the enabling technologies, not only related to integrated photonic circuit, but also for scanning system based or other, let's say, methodologies for LiDAR ranging, let's say. Also, another important thing are the simulation tools that can be used for simulating environment conditions. So this is also, I think, a very important aspect of the designing point of view, but also for the co-packaging of the system. So understanding what are the performance needed for the sources, for the detectors, knowing what are the limits introduced by the environment. So this is very interesting indeed.
For me, one of the key things that I have seen lately, and that's why I was very happy that Huawei joined the meeting, is that LiDAR is also joining reaching the consumer electronics market. So we have products now from I'm not going to mention brands that are not here. We have products now that are LiDAR enabled. Augmented reality is going to be LiDAR enabled. There's a startup, an amazing startup in Epic called LuxC. I don't know if the CEO, Mirvais Youssef, is listening to me, but if you are, hello. He's really bringing augmented reality enabled LiDAR solution. Do you think LiDAR is going to be a driver in consumer electronics as well?
Yes, I think so.
We have to really find out what are the demands, and of course I think VCSELs are already there, so we already have the light source, but there's a lot of demands when it comes to make a whole LiDAR integrated, and I'm very happy that Huawei is a member of Epic. I'm going to move on to Pierre from LeddarTech.
Thank you.
We talked a lot to many of the different companies. Some of them are competing with you, some of them are helping you, some of them can actually buy your LiDAR solution. What did you learn out of this meeting, and what kind of cooperations do you think you can do afterwards?
Well, certainly, like at a high level, we're looking to collaborate with everybody. Certainly, photonics ICs or silicon photonics are certainly an intriguing development, and from a capacity to increase the level of integration and to meet some of the cost points. So certainly, from my standpoint, that's one of the areas where I want to do further research, and certainly I'm welcoming contacts.
We covered the automotive with you. We covered with the company PLX in New York. We covered the aerospace and space market. Michelle, you are one of the companies in Epic that helps the different component manufacturers building systems and putting them in the harshest of the environments, which is the one beyond the stars. What did you learn from this meeting, and what kind of cooperations do you think you can do afterwards?
Hey, so I think I learned a lot about all the different types of applications in LiDAR and all the analysis that you can do. That was really interesting with the optical software portion. But from PLX standpoint, we really provide a lot of different solutions in high precision optical assemblies. So we do monolithic structures and variant systems. And so some of the other things that you was talked about in LiDAR, this ruggedness that was looked for, I think, in the Facebook presentation, this reliability. Our systems are really at the core perfect for that. So these systems are athermal design. They have a lot of high vibration, shock, thermal excursion. So even with these high precision and really great accuracies down a sub-arc second. So we basically take beams and laser beams, and we can do beam deviations that are high accuracy. So I think this would be a perfect collaboration with a bunch of these other partners in this industry.
Ünsal, we started with you, we finish with you. What kind of goodbye message from the tier 1 supplier that we have in the Epic network do you have, and what kind of questions you still remain for the rest of the supply chain?
I try to find now the Zoom window here. Okay, hi. Yes, can you please repeat? I was just 1 minute off.
Yes, of course. We started with you, we finish with you. What kind of cooperations you want to do with the supply chain that you have in front of you?
Yeah, so basically it's the same like the colleague from LeddarTech. We are looking in a lot of disciplines. We have a massive research in VCSELs and SPADs technologies, and yeah, like it's kind of an Olympic thinking. So it's always going wider and faster, and so we are looking to develop our technology further. So if we look on 10 years ahead now, with all fully autonomous driving cars, maybe, or with a higher level of automation, we need high-performing sensors. So not only LiDARs, also cameras, also radar sensors, and they play well each other. So the whole value chain is needed here to collaborate. So it's not a one-man show here.
Fantastic. I would like to remind everyone that Sana and me did our best to chair the meeting, but of course we cannot chair the follow-up. The ball is now in your court. Also for the people in YouTube, Please remember that the purpose of this meeting is to contact the speakers and to do business with them. So please, this is my email address. If you don't have the email contact of any of the speakers today, send me an email. I will be very happy to bring you in touch with it. Our job and our passion is to bring the industry together. Thank you very much for these 2 hours and 37 minutes that I really, truly enjoyed. Until the next time, continue being epic and stay at home. The virus thing is almost over. Stay at home and be optimistic. See you soon. Bye-bye.
See you. Bye-bye.
Bye-bye.
Bye.